The water level is rising above the largest dam in the world, the Three Gorges Dam. The authorities have no choice but to open the spillways. It's a beautiful sight, but can you spot a major design flaw? You're right. This water ejecting at high speed could erode the soil around the foundation, and finally, the clever engineering of these Chinese engineers install these concrete chutes. These chutes eject the water upward into the air, where it breaks into small droplets. These droplets land nearly 100 meters away from the base of the dam. At that distance, the fine mist doesn't pose any threat to the dam's foundations. Observing the path of this spillway water is fascinating. But the big question is how such a massive concrete structure was built in a location that was originally a powerful, free-flowing river, the Yangtze River. To construct the dam, engineers didn't use a traditional river diversion technique. Instead, they used ingenious methods. Build 2/3 of the dam first and the final third later. Initially, they constructed a stone cofferdam in the 2/3 width of the river. Can you tell what will happen to the river flow now? The river has no issue. It will flow through the remaining 1/3 region. The riverbed is dry inside the cofferdam region. They built a major portion of the dam here. The main thing to be noticed here is that one portion of this dam construction has a series of spillways. Currently, all the spillways are shut by the sluice gates. Now, the engineers dumped and blocked a huge amount of earth on the flowing river. You may think this will lead to a catastrophe, that the river height will increase and the water may overflow the dam. Here comes the trick. Along with the earth dumping, the engineers gradually opened the spillways in the constructed dam. This way, even though the entire river is blocked, the water level of the river is kept under check. This is a genius technique, right? Now that the river is under control, the engineers built another cofferdam on this dumped earth. Now, the last section of the dam can be built. Finally, the cofferdam can be removed. In short, in the initial stage of the construction, the channeled river helped keep the river height in check. In the final stage of the construction, the spillways kept the river in check. This was obviously a genius construction method which avoided the need for traditional and costly river diversion. As the river height increased, it spread to more areas. Many hectares of land literally went under the water. Obviously, the people living in these areas had to be evacuated before the dam construction. This is how the dam construction affected the shape of the Yangtze River. In the upstream, the water height increased and became more concentrated, while in the downstream, it narrowed. Our planet, the Earth, experiences a small issue due to this massive water level concentration. The huge amount of water stored causes a strange problem. It slows down the Earth's rotation.
When I keep the mass slightly away from the spinning globe, it slows down. When I keep them closer, the speed increases.
By raising 39 trillion kilograms of water to 175 meters above sea level, the Three Gorges Dam essentially moved a massive amount of weight further away from the Earth's axis. This, in fact, increased the moment of inertia of the Earth. According to NASA scientists, the moment of inertia shift caused by the dam slowed the Earth's rotation by 0.06 microseconds every day, or 2.2 seconds after 100 years. Of course, 0.06 microseconds is an incredibly tiny fraction, but remember that this permanent change to Earth was done by a human-made concrete structure. But you could see another major issue right in front of your eyes. What will happen to these cargo ships after the construction of the dam? The Yangtze River is a busy shipping route. Approximately 80 cargo ships transit through this region every day. The authorities were determined that this massive dam should not stop the busy ship traffic in this area. Their solution? Ship elevators. What you see very near to the dam body is the world's largest ship elevator. The ship enters a giant water-filled basin, and the entire basin is physically lifted up the face of the dam using a cable counterweight arrangement. Engineers gave the utmost importance to the safety and stability of the ship lift. The engineers had to invent an electrically powered rack and pinion and screw technology to provide this massive lift of 113 meters with sufficient stability and safety. The lift is completed in just 40 minutes. The Three Gorges Dam has more than one ship elevator mechanism, one that resembles the Panama Canal's water locks. This is a 5-stage ship lock. It consists of 2 lanes, one for upstream and one for downstream, with 5 distinct water steps. Let's analyze the procedure for ship lifting. A ship enters a chamber, the gate closes, and water is pumped in to match the water level of the next chamber. The ship then sails forward to the next step. This process is repeated until the ship reaches the water level of the dam. Because the ship has to stop and wait for water levels to equalize 5 separate times, the transit takes about 3 to 4 hours. The Three Gorges Dam produces more than 10 times the power of the Hoover Dam. The Three Gorges Dam stores water at a whopping 110-meter height. Remember, the 175-meter figure we mentioned earlier was measured above sea level. This massive turbine generator system is waiting to receive this water. The Three Gorges Dam has 26 massive penstocks that feed the main powerhouse turbines, each with a 12.4-meter diameter. Meet this elegant and gigantic machine, the Francis turbine, which performs this impressive energy extraction. The water which flows down through the penstock finally reaches a set of 32 Francis turbines, each with a capacity of 700 megawatts. The diameter of the runner is 10 meters. Interestingly, these turbines spin very slowly, just 75 revolutions per minute. These turbines operate with an impressive efficiency range of 94% to 96.5%. The high-energy incoming water, when it finally leaves, is left with only 5% of its energy. These 32 turbines are situated in 3 different powerhouses, on the left bank, the right bank, and finally, underground. If you turn the camera upward a little bit, you'll meet the real heroes of this project, the generators. They are coupled directly to the turbines. They are salient pole synchronous generators. They produce 50 Hz electricity at 75 RPM. The generators need 80 poles.
Unlike most major infrastructure projects in China, the Three Gorges Dam faced significant internal pushback. The emotional turmoil of 1.3 million people who were forced to relocate was unimaginable. Moreover, the rising waters were said to submerge over 1,000 known archaeological sites, including the ancient hanging coffins of Bo people and Zhangfei Temple. The authorities had to bear the emotional toll of overseeing the dismantling of 1,000-year-old structures to make way for a concrete dam. Despite all the odds, the construction of the Three Gorges Dam progressed.
The concrete dam body itself is an engineering wonder. It has a complex internal cavity to accommodate various facilities. This means the concreting technology they used must also be super smart. The Three Gorges Dam required the placement of approximately 27 to 28 million cubic meters of concrete, a volume so massive that traditional construction methods would have taken decades to complete. To complete the project on time, the Chinese needed record-breaking concrete pouring. The American construction giant Rotech Industries accepted this challenge. Instead of intermittent skips or buckets, the Three Gorges Dam used a high-speed continuous conveyor system. You can see a giant factory near the dam site. Let's get into how this fully automated Rotech system works. To achieve concrete of great strength, gravel of different sizes must be mixed with cement. This is a fundamental principle in concrete technology known as gradation. The primary reason for using different sized gravel is to create the densest possible structure by minimizing voids. Also, well-graded concrete has better workability. In this region, the mixing of different sized aggregates takes place, and after mixing, the aggregates enter a cooling system via a conveyor belt. Here, cold air is blasted over them to lower the temperature. Now it's time to add cement to this mixture. An auger transfers cement to the next mixing chamber. The final mixing happens here. You can see that instead of using water in liquid form, the Chinese used shaved ice. You might be wondering why they try to reduce the temperature at every stage. This is crucial for the temperature control of the dam body. We'll learn more about this topic later. After the aggressive mixing, the output reaches another conveyor belt. Please note that even during sweltering Chinese summers, the temperature of the concrete mix was just 7 degrees Celsius. Conveyor belts were covered and insulated to keep the temperature at 7 degrees Celsius. The new conveyor belt is different. It has a concave shape thanks to these inclined rollers. The concave shape is important to avoid any kind of concrete spilling out. The belt has to become straight in the region where the motor is powering it. The genius of Rotec is that they use multiples of such belt systems. After completing the journey on one belt, this is how the concrete gets transferred to the next belt. The way multiple conveyor belts work together to move concrete to the other end looks fascinating. If there is a sudden height change in the terrain, a long hopper should be used to accommodate the height difference. After hundreds of such units, the concrete has finally reached the top of the dam body. From here, the concrete reaches the final machine. The Rotec Super Swinger. Another conveyor belt carries the concrete to the machine. This machine has a brilliant mechanism. It can extend its boom in a telescopic style and can also rotate the boom nearly 180 degrees. Interestingly, this machine can perform these operations while the concrete flows over its belt. You may enjoy how accurately this machine is able to place the concrete at the intended locations with the help of these animations. You may see the counterweight adjustments the operator makes to balance the Rotec Super Swinger. Despite using such modern and fast technologies, the team took 7.5 years to complete the concrete pouring of the dam. In May 2006, the concrete pouring was finished. Apart from the rebars, you can notice a steel pipe arrangement inside these molds. These are in fact chilled water lines used for the temperature control of the concrete. When the concrete cures, it generates a lot of heat. In a gigantic dam like the Three Gorges that is hundreds of feet thick, the heat will get trapped in the center. Assume the center is 60 degrees Celsius, while the outside is 20 degrees Celsius. This means the internal concrete volume wants to expand, but the outside volume prevents this expansion. This will lead to massive internal pressure, and it would take decades for this temperature difference to disappear, resulting in catastrophic cracks. Engineers installed a circulatory system of thin-walled steel pipes, usually about 1 inch in diameter, throughout each block before the concrete is poured. Initially, cold river water is pumped through the pipes to absorb the high heat of the initial chemical reaction. Later, water chilled by a massive on-site refrigeration plant is circulated to bring the concrete down to its final equilibrium temperature. Now it's time to take care of these hollow steel pipes. These pipes are pumped full of grout under high pressure. This turns the hollow pipes into solid steel rebar, making them a permanent part of the dam's structure. The length of cooling pipes used for the Hoover Dam's concrete pouring was around 940 kilometers, but for the Three Gorges Dam, it was more than 10 times that, a whopping 9,500 kilometers. Now, you might be wondering how I collected all this information about the Three Gorges Dam. If you do a normal Google search, you will get almost nothing. Welcome to my smart method, the NordVPN method. Today's video is sponsored by NordVPN. The Chinese government obviously wants to keep the construction secrets of this mega dam a secret. Using NordVPN, you can make the internet believe that you are from China. Now have a look at the results. With my normal location, I cannot access these websites. Moreover, NordVPN is super useful for your internet safety. Think of NordVPN as a digital bodyguard for your internet. First, it hides your activity from hackers and advertisers by encrypting your connection. Second, it blocks annoying ads and scans your downloads for viruses, acting like a lightweight antivirus. Third, it is incredibly fast, meaning you can stream or game without that annoying lag older VPNs used to cause. It also checks if your passwords have been leaked on the dark web and lets you securely link your devices. In short, it makes browsing private, safer, and much smoother. Get an exclusive NordVPN offer, a large discount on a 2-year plan, plus 4 bonus months at nordvpn.com/Sabin, or click the link in the description below. If you visit the Three Gorges Dam construction site in summer, you'll be surprised to see an artificial fog around the site. Why was this needed? The primary purpose was to prevent thermal cracking. The artificial fog created a microclimate around the pore site. As the fine mist droplets evaporated, they absorbed latent heat from the surrounding air, effectively lowering the temperature near the concrete surface by several degrees. The dense fog also blocked solar radiation. The high humidity also prevented rapid evaporation of water from the concrete mix. You might be wondering what these workers are doing on the poured concrete. They are using multi-arm vibrating machines. While concrete looks like a simple fluid when poured, air naturally gets trapped within that mix during the pouring process. Vibration forces the trapped air to the surface. These machines also push the liquid cement paste into every corner of the formwork and around the reinforcing steel. If the block construction of the dam body is done in this manner, a big danger awaits the dam. After filling the reservoir with water, you will notice water leakage via the block joints. Why is this happening? The villain is concrete latence. We know concreting is done in different blocks in this dam. As one block cures, a weak, milky layer of cement and fine particles called latence rises to the top. If the next layer is poured directly onto latence, the bond will be weak, leading to potential seepage or structural failure under the immense pressure of the Yangtze River. High-pressure water jetters, often exceeding 70 megapascal, are used to green cut or blast away this weak layer once the concrete has reached a certain hardness. This exposes the coarse aggregate, creating a rough, clean surface that allows the next pour to lock into the previous one mechanically. We know they completed the concrete pouring of the dam body in May 2006. The interesting thing is that almost 3 years before the dam body was complete, the engineers started to increase the water level height, the process of dam impoundment. This is the most stressful period for engineers. The dam body will be tested against sheer hydrostatic pressure of the water. The turbines have to be tested and commissioned stage-wise, and even surrounding mountains are tested for slope stability. Any mistake in the impoundment phase can turn disastrous for the biggest dam in human history. Welcome to the most crucial part of the Three Gorges Dam project, which lasted more than 7 years. Filling a reservoir of this scale, 39.9 billion cubic meters too quickly, can be catastrophic. To increase the water level, the authorities just needed to close the sluice gates. But there is an issue. When the impounding started in 2003, the construction of the right bank was not even complete. The main wall in this area was only at an elevation of roughly 80 to 140 meters in various blocks. This increase in water level will easily overwhelm the temporary cofferdam. Authorities need to keep the right bank section dry for the workers' safety. So the authorities first had to build an RCC cofferdam around this section. The new cofferdam acted as a shield, and the concrete pouring work of the right bank continued in full swing, while engineers closed the sluice gates one by one and started to raise the level of the water. Today, June 1st, 2003, the engineers are starting the first phase of water impoundment. They have to raise the water level from the current 66 meters to 135 meters. This simple-sounding job is in fact the scariest part of the project for the engineers due to many reasons. Did you see the thousands of piezometric and inclinometer sensors installed on the banks of the Yangtze River? What's the need of it? As the water level rises, it saturates the soil and rock on the banks of the reservoir. This increases pore water pressure, which acts like a lubricant between rock layers. If filled too fast, the slopes can become unstable and trigger a massive landslide. Such a catastrophe had happened in the Vajont Dam in Italy, a massive landslide due to the rising water level and dam overtopping. These sensors sent real-time data and helped in avoiding any misdeeds. Phase 1 was completed in just 15 days, and the engineers raised the water level from 66 to 135 meters. This provided enough head to begin testing the first set of the turbines. The water level remained at nearly 135 meters for the next 3 years. During this phase, slope stability of the riverbanks were studied in great detail. One more issue the engineers need to worry about is induced earthquakes due to sheer weight of the water, roughly 42 billion tons. At full capacity, the massive weight of the water actually deforms the Earth's crust. This immense pressure can force water into existing fault lines, potentially lubricating them and causing earthquakes. Engineers maintained a dense seismic monitoring network. By filling the dam in stages over several years, they allowed the crust to settle and adjust to the new load gradually.
Today is May 20, 2006. You can see a small ceremony behind me. Today, the final concrete pouring was done to the dam body. In short, the biggest concrete pouring in human history has come to an end. In fact, the Chinese achieved the completion of the core structure body 10 months ahead of schedule. Quite impressive.
Phase 2 for water impoundment was done only after the dam body was complete. The water level was raised to 156 meters. This 3-year delay in Phase 2 impoundment had one more advantage. Even though the dam body is finished, the concrete in this region was relatively new and still curing. This means the internal volume of the dam body is still under high temperature. If the water was raised in a hurry, the cold temperature of the rising water will cause a steep temperature gradient. As we learned earlier, this will cause thermal cracking. Phase 3 was from 2008 to 2010. The reservoir was finally brought to its maximum design level of 175 meters. The first time it reached this peak was in October 2010. During this entire impoundment phase, the dam was monitored by over 12,000 instruments embedded in the concrete. They measured how much the dam bent under the water pressure, seepage through the foundation, and even uplift force on the dam body. This is how the largest dam in history was constructed and commissioned. The Three Gorges Dam is a type of dam known as a gravity dam. A gravity dam uses its own sheer weight to resist the horizontal pressure of the water pushing against it. Here, things become interesting. Three Gorges Dam is undisputedly the largest power production facility in the world. However, some argue that Itaipu Dam of Brazil produces more power than the Three Gorges Dam. What's the reality? The Three Gorges Dam has 60% more power production capacity than the Itaipu Dam. Despite this, the Three Gorges Dam does not always produce 60% more energy. In fact, for many years, Itaipu produced more total electricity than the Three Gorges. The Panara River of Itaipu Dam has a very steady year-round flow. In contrast, the Yangtze River is highly seasonal. During the dry season, many of the Three Gorges turbines have to sit idle because there isn't enough water to spin them all. Due to this, Itaipu operates at a capacity factor of 80 to 90%. The Three Gorges usually operates at a lower average capacity factor, roughly 45 to 50%. In 2016, the Three Gorges Dam was in second place with an energy production of 93.5 terawatt hours. In the same year, Itaipu Dam produced an energy of 103.1 terawatt hours. Three Gorges eventually reclaimed the title in 2020 when it shattered Itaipu's record by producing 111.8 billion kilowatt hours, thanks to a particularly heavy monsoon season that provided an immense and steady volume of water. The second major objective of this dam is flood control. The Three Gorges Dam is doing an incredible job in controlling the flood in central China. This dam is not a magical remedy for China's flood problem, but the dam has reduced the chance of flood for 1 in 10 years to just 1 in 100 years. This gigantic dam is not without controversies. In 2019 and 2020, satellite images, primarily from Google Maps, went viral, showing the dam appearing severely wavy or buckled. The social media claim was that the dam is warping under severe hydrostatic pressure and may collapse at any time. However, the officials confirmed that these images were the result of satellite imagery distortion. Satellite photos are orthorectified, stitched together from multiple angles and elevations. If the underlying terrain data or the stitching algorithm is slightly off, straight lines appear warped. The greatest long-term challenge for the Three Gorges Dam is its sediment problem. When you slow down a fast-moving, sediment-heavy river like the Yangtze, the sand and silt naturally drop to the bottom. If left alone, the reservoir would eventually become a giant mudflat. Engineers are fighting this problem with the store the clear, release the muddy strategy. During the summer flood season, when the water carries the most sediment, the dam opens its lower silt-flushing gates. This allows high-velocity, muddy water to pass through. During the winter, when the water is clearer, the gates are closed to store water. Remember, this is not a perfect solution. This method only removes approximately 30% sediment. The real issue is at the downstream side. The water, which is downstream and less in sediment, is in fact hungry for sediment, and it has the energy to eat the riverbed and banks downstream. The Yangtze riverbed below the dam has lowered by several meters in some areas. This can undermine the foundations of bridges and cause riverbank collapses. The sediment, which is piling up in the bottom of the dam, was in fact a free fertilizer. Historically, the Yangtze didn't just carry water, it carried living mud. Every summer, floods would deposit a fresh, millimeter-thin layer of silt across the Jianghan Plain and the Yangtze Delta. This silt was packed with organic matter, nitrogen, and phosphorus, nature's free fertilizer. The dam now catches about 70 to 80% of that sediment. The rice paddies of Hubei and Jiangsu are starving of nutrients. The farmers who once relied on natural flood pulses now have to use massive amounts of chemical fertilizers to maintain crop yields.
The Three Gorges Dam is incredible. So is the use of NordVPN in making your web surfing safe and more productive. Before you leave, please check out my special NordVPN page. It's risk-free with 30-day money-back guarantee. Take care. Bye-bye.